Good afternoon, ladies and gentlemen. My name is Sven Bode, as I was already informed you, from the company InfraTec in Germany. What we are doing thermographic solutions. These are infrared cameras, cooled ones. So I want to show you today some newest developments from InfraTec. Just a short introduction. First, I will give you a short introduction about InfraTec at all. The InfraTec thermographic cameras, ImageIR, which we are producing and developing. And then our newest product, firstly presented today to you. I will show you how to multiply your pixels by 4 of a standard mid-wave camera, of course, an InfraTec camera. So first, greetings from our headquarters in Dresden, Germany, which is a little bit on the east-south. These are our facilities with some warm cars, so people arrive late sometimes. So our mission is being a specialist in infrared technologies and offering the best solution and service for our customers. So some facts: we are founded in Dresden in 1991, just after the war fall. It's still private owned. We are around 200 people located in Dresden, and we have a sales of about 27 million euros per year. We have 2 business units. One is the sensor division, and the other one is the infrared temperature measurement division, where I'm standing for. The sensor division is doing small sensors, very complex sensors, which are all based on optical sensing, so for pyrometry, for fire detection, for gas analysis, for every surgery you're going in with all the apparatus which are controlling your oxygen contents and CO2 contents. Mostly there are our detectors in there. So, and also for optical measurements in general. So we are producing them here, and we are developing. We have clean rooms, everything is done in Dresden. The second division is the infrared temperature measurement division, where we mainly doing thermographic systems for research development, non-destructive testing, process quality control, predictive maintenance, and these are the main fields. We are also offering turnkey solutions for process monitoring, automatic fire detection, and surveillance. But one of our most key points is that we are doing thermographic trainings for our customers and potential customers, of course. We're doing thermographic services. We have an own laboratory for completely equipped with all NDT stuff you can think about. And we are doing services, and people also can visit us to do their own impression. We have thermographic software, even customized. If you need some very special solutions, we will do this. Some pictures or some information about the company. So we are doing the engineering of our cooled cameras completely by our own. So we are doing the optics, mechanics, electronics, and software in-house. We have a well-equipped calibration lab with climate chamber, or what you need to do the correct calibration. But also we have turnkey solutions, for example, fully equipped, ready-to-use brake analysis systems. So this is a brake disc from both sides, simultaneously recorded with infrared, and you can see that it's not left and right, it's not the same temperature distribution, and it's sometimes very interesting for the producers. Also, we have automatic solutions, welding inspection, line welding inspection automatically, where our cooled cameras are equipped on the head of the robots, and with a flash, high energy will be put into the material, and we will see the response, and we can say it's good or not. So our infrared cameras called ImageIR can go down to 30 millikelvin NETD or even less, up to 25,000 frames per second, up to 1920 by 1536 native pixels, IR pixels. We can go down to 1.3 micrometer resolution per pixel in theory, but we have also the lenses for this. And our interface is 10 dB optical interface, which is rather fast, and we are doing this direct to PC. We don't need any other recorder in between. Also, one of our highlights is a double filter wheel. This is included in some of the cameras, or can be ordered as an option, 2 times 5 positions, so you have 25 combinations available. You can choose your own filters, you will equip them. Also, one thing is for geometric, it's very important to keep the lens section, the optical path, cool, because everything which is hot radiates infrared radiation, which we don't want to measure, but we have an offset or parasitic radiation. For this, we have a modular housing, and the module 1 here, the optical one, is kept cold by some very tricky engineering. So you can see this is the measuring line of our camera working after some hours. This is the a line, a profile line which is measured. This is a result. So the camera body itself, it's about 30 degrees C. We don't care because it's not the optical path, but the optical path is it's rather cool around room temperature. And believe me, it's really not after switching on. It's really after a timeline. On an exhibition, we had the chance to look on another brand of the same model, of the same kind of camera. Again, this is the measuring line for the profile. The camera itself is about 38 degrees C. Okay, no problem with this, but the optics, it's around 34, 35 degrees C. And this is a hint that this is not a stable temperature, and this will give you some problems by calculation or by calibration or by compensation of temperatures. Last year we presented the biggest FPA camera for midwave infrared. Still, it's the biggest commercial one. I did not see any competitor yet. So it's still available. We have it also in our booth in 350. You can still have a look on it. And this year we have something new. We want to show you how we do 4 times more pixels with a standard ImageIR midwave camera with an optomechanical microscan in front of the detector. How it's going to work. So this is a standard camera, infrared camera, visual camera. So we have an object, we have a lens. In this case it's an infrared lens. And this will be, the object will be illuminated or will be imaged on an FPA focal plane array. It's not as many pixels we have because we will not see them, and this is the infrared image. So this is a standard way of optical path. Maybe there's a filter in between, but doesn't matter. So we are doing the enhancement of the spatial resolution by some optical mechanical shifting of the optical path. So we introduce an image shifter, which is shifting the image in 4 directions. Sorry. And this is a filter wheel with the image shifters in there, and the image will be shifted over the FPA with a certain difference. This speed can go up to 5,400 RPM, so we can serve our fastest camera in full frame with 360 Hertz, so don't be sick. We can go even faster than this. So the MicroScan frame rate output is exactly the same as the detector frame rate. So we can use the full 300 Hertz, 360 Hertz or 355 Hertz to be exact output even with the microscanning unit. Some examples. So this is a test object with a structure over here of about 150 micrometers. This is the thermal image, the standard thermal image. And we are looking now at this part. This is the standard picture without microscan, and if you use a microscan, you see there's a difference. You can also split, and you see this is the without microscan, with microscan. And okay, here you still can see some structures, but when we go into a more fine structure, which is 75 micrometer, we go into this direction, you will see, if we look on the zoom, you know now the structure, of course, and you can imagine, but if you have microscan without microscan and direct comparison, which is split screen like now, you can see it's a big difference. So it helps you a lot to find the structure, because this can be everything. Now you know it, but if you just see it first time, you don't know what structure is behind it. So this option will be available for standard midwave cooled cameras. So at the moment we have an 8300 series which is based on a 640 by 512, not 250, sorry, it's a typo, 512 pixels, which we can enhance to 1280 by 1024 pixels. And the next step, within a few months, we will have the 9300 series, which is based on the 1280 by 1024 pixels, will be an image at the end of 2560 by 2084 pixels. This is a big enhancement. This option will be available for these cameras. Of course, you can say now, why do we do this? Because we have this camera. It's a price issue, of course. With this option, we can offer this option. We are planning to offer this option at around 5,000 to 7,000 euros or dollars as an additional option to our standard cameras, which is still far away from the next bigger step of camera with a real native pixel resolution. This is the reason why we're introducing this MicroScan. So if you want to see more of this, we have this camera down in the exhibition center at booth 350. You can visit us, you can look at the camera, you can switch on and off the MicroScan for you that you can see directly the difference. I'd like to thank you for your attention.
Thank you, sir.